All right, good day, everyone. Today we're going to be talking about our last activity dealing with logarithms. This one being solving a log equation. Okay, so we're going to take basically everything we've talked about, the change of base formula, our properties, everything like that, and then we're also going to use them to help solve certain log formulas. Okay. Now, in today's lesson, we're really going to be focusing on how do we cancel out a log, how do we turn exponentials into log, and then working off that. Okay, remember once again, the goal of log is to actually solve for an exponent. Okay, so a lot of the questions we're going to have today are going to be a variable up in the exponential part. So we have to think that whenever we get that situation, the really only way to solve it is using a logarithm at this point in time. So let's go ahead and start talking about it. Okay, just to kind of quickly go through this. This is kind of your first example where they have you using a compounded continuously interest rate, which means we're going to go back, pull back some information from a little bit ago, where we have the equation. My pen would work. The amount is going to equal, and then if you remember, for continuous, we're going to use that equation per. Okay, principal times the value of e to the exponent of rate times time. Okay. However, in this case, they basically want to know how long it's going to take for this to actually happen. Okay, they want to know the actual time. So for all these problems, we're basically trying to solve for this t value. Okay, so let's go ahead and get into it and start talking about this. Just to go through one of these real quick, basically want to know, using that equation of PERT, how long would it take from a original principal investment of 100,000 with an interest rate of 6.5% to reach 120,000. So I would set this up like so. We'd have 120,000 is equal to, once again, I'm doing letter A here, my original principal, which was 100,000, times the value of E. And then we had a 0.065 times the value of T. Okay. And we talked about in the other lesson how we really can't solve this. Like this equation right here, really, unless we use a logarithm or a graphing calculator, we couldn't solve it. So before we talked about how we would take away the 100 and then we would graph out whatever each side was, and we would find that intersection point because that would give us the time. Well, let's just say we don't have a graphing calculator. Let's say we just have like a regular scientific calculator that we want to use to actually solve this out. Well, let's talk about how we would do this. So first off, I have 120,000 equal 100,000 value of E to the exponent of 0.065 times T. Okay. So first and foremost, let's simplify this for ourselves. Let's divide this 100,000 over to the other side to get rid of it. Ooh. Early comma. Okay, that's going to cancel it out on this other side. And then this is going to come out to be 1.2. 1.2 is going to equal e to the power of 0.065, excuse me, 0.065 t. Okay, so right now this is where we're at. And we talked about the other day how at this position we're kind of stuck. We really couldn't solve it unless we actually found out how do we actually use logs. Well, in this problem, now that we have logs, I can actually solve this out by using a very simple step. Okay, we talked about how anytime you use a log with a similar base, it's going to naturally cancel itself out. Okay, the whole idea that we're going to use throughout this whole lesson is going to be, and sorry, we had one of those random lines pop up. It happens every once in a while. The whole idea that we're going to use is this process of, if I take ln to the value of E, these would cancel and I'd be left with a value of 1. Same thing if I use log base 2 to 2, same concept. This would cancel and I'd be left with just a value of 1. Okay. Really, it doesn't cancel out. It's just the whole idea is that if you have log base 2 and you want to know what the answer is, the exponent has to be 1. I use the word cancel just because it's a lot easier to explain when we're actually working these out. So when I actually work this problem out here, what I basically want to do is use this idea to cancel out this E. So what I'm going to do is I'm going to take the ln, or natural log, of both sides. Natural log of E to the 0.065 t. Okay. Now what happens at this point is we can actually use our properties to take this exponent and move it out front. We talked about the other day, anytime you have an exponent within a log function, our property says we can write it out in front of it. So really, I could rewrite this as natural log of 1.2 equals 0.065 t ln of e. Okay? Well, the nice thing is that the ln of e is just equal to 1. So this basically cancels itself out. And all I'm left with is the natural log of 1.2 equals 0.065, in which if I wanted to get the t by itself, I would just take this value, divide it over, and next thing you know, I have the answer that I can plug into the calculator. The time it takes to get to 120,000 is going to equal the natural log of 1.2 divided by 0.065. Okay, that I can just go to a calculator and plug right in. We have the natural log of 1.2 divided by 0.065. And to get an answer of 2.8. So it takes about 2.8, or if we round up, about 3 years to get to that value. Okay, so time is equal to 2.8. Okay, so once again, our whole process, and honestly, a lot of the problems we're going to go through today is going to follow this step, where I'm going to input my own natural log or log to actually get rid of that base. And by doing so, it cancels itself out and I can move on. Let's go ahead and talk about some other ones we might see. So let's say we have a problem like this, like an example B here, where we start with an exponential function. Okay, just to kind of make use of this, we'll go ahead and use this value here. Let's say we have 10 to the x minus 1 equals 270. Now, if I'm dealing with this currently, like we had in the last one, I can't really handle this situation. I can't solve for an x minus 1 until I actually get this outside of an exponent. The only way to do this is by using log. Now, in this problem, I need to somehow get rid of a 10. So I need to basically plug in a log base of 10 to the 10x minus 1 equals, so notice how I plugged in a log base of 10 here, which you could also just write log, because that would also work. But whatever I do to one side, I also need to do to the other. So I have to do log base of 10 of 270 on the other side. So all I'm doing to really simplify this equation is plugging in a log base 10. Well, because of that, I can take this x minus 1 and move it out in front. And then this value is going to just cancel and become 1. So really, all I'm left with here is x minus 1 is equal to log base 10 of 270. Okay? My last step would be to add the 1 over to get x equals log base 10 of 270 plus 1. So then my process here would be the same thing. I'm going to go to the calculator. I'm going to hit, in this case, I don't need to actually plug in a base. Once again, if I just hit log in the calculator, that represents log base 10 of 10, or excuse me, log base 10, it was 270. So we have log of 270 plus 1 to get an answer of 3.43. Okay. So my final answer for this one would be x equals 3.43. Now, this is a simplified version of this. And once again, I'm kind of just giving you the basics within this lesson, okay? When we get to class tomorrow, when we get to class on Monday, we're going to be talking about a lot more complex values like letter D, where we have to do other things within it. But the idea of it is what's important. If I ever want to solve to get any x value in an exponent, like we see here, what I need to do is I need to use my logs to actually move this value out in front and then cancel it out. Okay? So that being said, let's talk about, I think we have one more type of problem, or we have two more types of problems, excuse me. So let's talk about this one, example C. Okay, once again, we'll go through one quick problem of it and then kind of work off of that. So in example C, we have the other route. So in the first two problems, we dealt with a problem that was starting off in an exponential form. Well, what happens, or how do we actually work with something that actually starts off in, well, regular log form? What if I get a logarithmic form? How do I actually simplify it? How do I cancel it? Well, if we talk about letter A here, we have 2 natural log of 3x equals 12. Well, if I'm trying to think, how do I actually solve this out? First and foremost, let's actually get this out, or this natural log by itself. So to do this, we have to start by getting rid of that 2 in front, because it's the one thing that's not connected to the natural log. It's being multiplied to it. And we have the natural log of 3x equals 6. Well, now the idea is that basically I need to somehow cancel out the natural log. Well, we always have to think inverses. Think about what opposite of natural log is. Well, to do this, what I'm going to do is basically take each of these values and create exponents, okay? Because once again, that's what log is dealing with. So what I'm going to do is I'm going to take this power, I'm going to go e to the ln of 3x equals e to the power of 6. So notice how all I did was take both of those values that we have up here and put them as exponents with a base of e. Now, once again, using our ideas, if the bases are the same, then the exponents have to be equal. So technically, this is still good math because these two exponents, natural log of 3x, still has to equal 6 because the bases are the same. But the reason why this is helpful is because now, with using our inverse idea, this should just cancel itself out. And what I'm left with is 3x equals e to the 6th. At this point, if I wanted to solve for x, I would just have to divide the 3 over. E to the 6th divided by 3. We go to our calculator. This would be second e to the 6th, which would come out to be 403. And then you just divide that by 3 to get 134.4 as our answer. So this comes out to be x equals 134.4. Now, like I said, this is kind of the basic idea of this function. Now, we always want to try to use that base to cancel it out. Okay, one thing that I can kind of point out, just because we used a natural log there and we used a value of e to cancel it, if we looked at our example, notice that if we are given a log base of 2, we use a 2 to then cancel it out. So we're always going to use that base value as what's going to be the indicator of how we're going to actually get rid of this log, okay? So the last type of problem we're going to talk about is how do we actually take a whole property and then simplify it. So if I look at this last one, I'll try these D, letter A. I'm given another situation where I have log base 2 of x minus log base 2 of x minus 1 equals 1. Well, here's where I run into a problem. In all the other problems, we were given a single value, one singular log or one singular exponent. In this case, I'm given multiples. So this is where we have to combine all of our knowledge together. I need to use our properties to then simplify this. Okay, I can't have 2 separate logs. I need to have a single one. So what I can do to start with is take our idea that subtraction, anytime I have subtraction between logs, I can combine them together using division. So this is going to be log base 2 of x divided by x minus 1. Notice how by using our properties, now I've given myself an opportunity to actually simplify this. Now, at this point, because I have a singular log, I can just simplify this by using our rules. I have a base of 2, so I'm going to put everything to a base of 2. Log base 2 and 2 are going to cancel itself out. So right now I have x over x minus 1 equals 2 to the first power is just going to be 2. At this point, all we have to do is really just use our algebra to simplify this out. I'm going to take the x minus 1 that's on bottom. Oh, hold on, didn't want that one. X minus 1 on bottom and multiply it to the other side. This will give me x equals 2 x minus 1. Distribute the 2 through to get x equals 2x minus 2. Subtract the 2x to the other side to get the x's by themselves. This would give me negative x equals negative 2. And then last but not least, divide out by negative 1 to get x equals 2. And just like that, I've gotten to my final answer. Okay? So just to kind of recap this last one, note, we're following the same process. We are following the same process of the fact that I'm taking my logs and I'm combining them so I can actually take this step here to cancel them out. Unfortunately, if I kept them separate up here, I could not do that step. Okay, it doesn't work when you have separate logs. We can only do that step with a singular one. So that's why we have to use our properties to actually simplify it out. Okay. We'll be going through some of the more complex ones in class the next day. So if you have any questions about this, please bring them to then. But besides that, hope you kind of are starting to get some of this material, and we will go over it on Monday. Besides that, have a great day.